Hello, I'm Dr. Millicent Thomas. In this video, I would like to explain about the joint density function and the marginal density function for a continuous random variable. So let us see in detail how to find the marginal density function from a joint density function of a continuous random variable, and also we can discuss about the cumulative density functions. The joint density function is usually denoted by the symbol fxy of xy, where it has the two basic properties that each probability is greater than or equal to 0 and the total probability must be 1. When you are trying to find the total probability, if it is defined in a wide range, then you will have integral negative infinity to positive infinity, integral negative infinity to positive infinity of either dx dy or dy dx, and that must be 1. Or if a range is defined, say you'll have integral a through b, integral c through d of f of xy dy dx must be equal to 1. The reason why we are finding the integral here instead of taking the summation, when it is a density discrete distribution, you may get the summation, whereas for a continuous distribution, you have the limiting case of summation because it takes all possible cases between that interval. You have infinite number of values between the given interval. So it is the limit of the sum. The limit of the sum is nothing but the integral. And that's the reason for a continuous distribution, you always have an integral negative infinity to positive infinity, integral negative infinity to positive infinity of whatever density function you have. Integrate that with respect to x and y or y and x, and that total probability must be 1. Let us discuss an example. Let us assume that the density function f of xy is given as a constant c times xy plus x plus y, defined in this range x lying between 0 to 1 and y lying between 0 to 1, and the function is defined as 0 otherwise. Now, first of all, we have to find what the constant c is. In order to find the constant c, we make use of the condition that the total probability is 1. In order to find the total probability, we have to find the integral between the given range, negative infinity to positive infinity, negative infinity to positive infinity of this function with respect to x and y. But here in this particular problem, x varies from 0 to 1 and y varies from 0 to 1. So the limits are, you'll have x varying from 0 to 1, y varying from 0 to 1 of whatever density function you have, integrate with respect to y and x. So when you integrate this, you get the final answer as 5c by 4. This 5c by 4 must be 1 because the total probability is 1. So from this, you can easily get the constant c as 4/5. The graph of this density function can be obtained using some graphing utilities like MATLAB or graphing calculators, say TI-92 or something like that. You get a three-dimensional diagram like this. Suppose we have to find the probability of x greater than or equal to y. So when you want to find p of x greater than or equal to y, initially the density function is defined in this range 0 less than or equal to x less than or equal to 1, 0 less than or equal to y less than or equal to 1. So you have the positive side of the x-axis, positive side of the y-axis. Say here x is 0, x is 1, y is 0, y is 1. So you need to find the function is defined only in this region. Otherwise, it is 0. So this is the density. The density curve must be defined only in this region. We are trying to find p of x greater than or equal to y. So let us see what this line is. Suppose if I would like to find what is y equal to x, y equal to x is this curve here. This line is y equal to x. When x is greater than or equal to y, we have y less than x. X greater than or equal to y is the same as y less than or equal to x. What is y less than or equal to x? We are interested in finding all this area here. See? So when you're trying to find the integral for this density function, the region of integration should be this shaded region, the green shaded region here. What are the limits? The limits for x ranges from 0 to 1 and y ranges from a point here to a point on this. So y varies from 0 to a point on this line. See here, if I take a strip here, the y value ranges from 0 to a point on this line y equal to x. So the limit is y varying from 0 to x varying from 0 to 1 of this density function 4/5 of xy plus x plus y. You have to integrate with respect to y first and then with respect to x. So when you do this calculation, you will get your final answer as half. If you want to find the joint cumulative density function, we are interested in finding capital F. By definition, we would like to find the probability of x less than or equal to x and y less than or equal to y. So the limit must be x ranging from negative infinity to y and y ranging from negative infinity to x. Instead of taking this as x and y, we can treat that as st. So this is your dy dx. Your x is taken as s and y is taken as t. So here y is t here and x is s. The reason why you are taking as s and t is since the upper limits are x and y, if you retain that as x and y, it will be confusing. So convert the variable x and y to s and t, and it will be easy for you to find the integration with respect to x and y or with respect to s and t. Finally, let us see what the marginal density functions are. The marginal density functions are nothing but the PDFs, the individual PDF. Instead of taking two variables from the joint density function, we are trying to find just the single probability density function of x or the density function of y. The formula to find the marginal density function is you are trying to find the PDF of x. PDF of x is obtained by varying the value of y. So since you are varying the value of y, all possible cases of y, so you are integrating with respect to y of xy. And the same way, marginal density for fy will be the integral with respect to x. You are varying x or you are taking all possible cases of x. Using the above previous formula, let us see whether we can find the marginal density for the given problem. The given problem was we got the value for C. C is 4, 5, and this is the density function given. Let us try to find the marginal density functions. That is, we have to find these PDFs fxx and fyy. Since fxx is nothing but integral of y dy, the y varies between 0 to 1, so when you integrate you get this answer. The same way, if you are trying to find the marginal density function of y, which is nothing but the PDF of y, you have to vary the values of x. So x ranges from 0 to 1, and even here in this case, you'll get the answer as the same as the previous one because the limits are the same. So in this video, we were discussing the joint density function for a continuous random variable, and also we calculated the marginal density functions. The marginal density functions are nothing but the individual PDFs, the probability density function of x separately and the probability density function of y. Hope this idea is clear and hope you enjoyed this video. Thank you for watching.